Hello students, so here I am going to discuss some of the problems of work, energy and power NCERT example problems. So let's start with the first question. Electron, proton moving under the influence of mutual forces in calculating the change in kinetic energy of the system during the motion. One, ignore the magnetic force on one another. This is because as we are talking about calculating the change in kinetic energy, we know that work is equal to change in kinetic energy according to work energy theorem. So work is equal to change in kinetic energy. But here they are saying that we are ignoring the magnetic force effect on the system. We are ignoring the magnetic force of one particle on another. Both are the charged particles. So students, whenever you are going to study the magnetic forces chapter in 12th class, these magnetic forces basically do not do any type of work. Magnetic forces simply change the direction of motion of the particles. So magnetic force formula is simply F is equal to Q v vector cross b vector. Here capital B is the magnetic field, B is the velocity vector, and q is the charge on the particle, and this F is known as the magnetic force, or we can simply call it the magnetic Lorentz force. So this magnetic Lorentz force simply changes the direction of the motion of the particle and does not do any type of work on the particle. So magnetic forces does not work on each particle. So because of this reason we are not considering the magnetic forces in this interaction. So let's now come to the second question of exemplar. Proton is kept at rest and positively charged particle is released from rest at distance d in its field. So basically we have a positively charged particle, that is proton, and around proton, like this is proton, let's suppose positively charged. So this is the region of the field of proton. Around the proton, this is the field of proton, and we release another particle from rest at distance d in its field. Let's suppose we have any other particle at distance d in the field of proton. So that particle, consider two experiments, one in which the charged particle जिसको हमने release किया है it is also a proton, and in the another experiment the other particle released is positron. Positron is basically the anti-particle of electron, and positron have the same amount same properties like of the electron, but it is positively charged. So this other particle is positron, that is known as the anti-particle of electron. So in the same time t, the work done on the two moving charge particle is, so हमसे पूछा जा रहा है कि like we are simply, हम यहाँ पर दो particles को जो है वो release करते हैं from rest. One is positively charged, other one is also positive charged. Other one is proton and another one is positron. So students, to positron है, it is the anti-particle of electron, also having the same charge of proton. दोनों का charge same है, लेकिन positron is a lighter particle. Positron is lighter particle in comparison to proton. सो क्वेश्चन इज दैट वर्क के बारे में पूछा जा रहा है इन सम टाइम टी. सो इसका जो सही आंसर है वो है वर्क more for the case of positron, as the positron moves away larger distance, because basically as we know that work is equal to force into displacement. So both of the particles are having same charge, and the force involved on the particle is basically electrical force, and the expression for electrical force is F is equal to QE. Q is the charge of the particle, E is the electric field created by the proton which is in rest. So here what is d? D is the displacement. As positron is a lighter particle, so its displacement in time t is more in comparison to proton. So that positron will cover more displacement. So because of that, work done in time t is more on the positron in comparison to proton, because it is lighter, it having more displacement in same time t, and proton have less displacement. So in case more of the positron, as the positron move away larger distance. So option C is the correct answer for this क्वेश्चन नंबर 2. सो स्टूडेंट्स आगे चलते हैं क्वेश्चन नंबर 3 की तरफ. मैन स्क्वेटिंग ऑन द ग्राउंड गेट्स स्ट्रेट अप एंड स्टैंड डाउन. सो एंड द फोर्स ऑफ रिएक्शन ऑफ ग्राउंड on the man during the process. So man is squatting on the ground, gets straight up and stand. The force of reaction of ground on the man during the process. So एक आदमी है जो कि स्क्वाट कर रहा है, ऊपर उठ रहा है, फिर नीचे जा रहा है, ऐसा कुछ प्रोसेस कर रहा है, गेट्स स्ट्रेट अप एंड स्टैंड. सो नाउ द फोर्स ऑफ रिएक्शन ऑफ ग्राउंड. सो ऑब्वियसली देखिए, जब जो आदमी जो है वो स्टैंड ऊपर की तरफ उठेगा, सो वो जमीन के ऊपर जो है एक्स्ट्रा जो है फोर्स एक्सर्ट करेगा. सो बिकॉज ऑफ दैट रिएक्शन ऑफ ग्राउंड ऑन द मैन ड्यूरिंग द प्रोसेस ऑफ स्ट्रेट अप, जब ऊपर उठने की जो बारी आएगी उसकी, उस वक्त जो है वो एक्स्ट्रा फोर्स एक्सर्ट करेगा ग्राउंड के ऊपर, एंड बिकॉज ऑफ दैट रिएक्शन ऑफ द ग्राउंड इज ऑल्सो मोर. सो वी कैन से दैट करेक्ट आंसर इज ऑप्शन डी, एट फर्स्ट ग्रेटर देन एम जी एंड देन लेटर बिकम इक्वल टू एम जी. बिकॉज जैसे ही वो उसका लाइक स्टैंड अप होना है, उसे ऊपर की तरफ उठना है ग्राउंड से, तो उस समय जो है वो रिएक्शन फोर्स जो है ग्राउंड का ज़्यादा रहेगा. तो उसे ऊपर उठने के लिए एक्स्ट्रा फोर्स एक्सर्ट करना पड़ेगा ग्राउंड के ऊपर, एंड बिकॉज ऑफ दैट जो रिएक्शन फोर्स रहेगा ग्राउंड का वो भी ज़्यादा रहेगा. सो इस वजह से एट फर्स्ट रिएक्शन ऑफ ग्राउंड ऑन द मैन इज मोर देन द एम जी, बट देन जब वो ऊपर उठ जाएगा सो देन इट विल सिंपली बिकम एम जी. सो एट फर्स्ट इट इज़ ग्रेटर देन एम जी एंड लेटर बिकम्स इक्वल टू एम जी. आप इसे सिंपली रिलेट कर सकते हैं. जब आप स्क्वाटिंग कर रहे हैं तो जब आपको ऊपर उठना है, ऑब्वियसली यू हैव टू एक्सर्ट एक्स्ट्रा प्रेशर ऑन ड ग्राउंड व्हेन यू आर, आपको ऊपर उठने की बारी आती है. सो इस वजह से इसका जो आंसर एट फर्स्ट ग्रेटर देन एम जी एंड लेटर देन बिकम इक्वल टू एम जी. सो सॉल्यूशन डी इज द आंसर. डी इज द आंसर फॉर दिस क्वेश्चन. Now let's come to question number 4. There a cyclist comes to a skidding stop in 10 meter. During this process, the force on the bicycle due to the road is 200 न्यूटन एंड डायरेक्टली अपोज टू द मोशन. सो साइक्लिस्ट है वो स्कीडिंग स्टॉप रुक जाता है 10 मीटर खिसकने के बाद स्कीडिंग स्टॉप. एंड ड्यूरिंग दिस प्रोसेस साइकिल के ऊपर जो फोर्स लगती है रोड की वजह से वो है 200 न्यूटन का एंड डायरेक्टली अपोज टू द मोशन. सो मोशन से उल्टा है वो रुक जाता है. द वर्क डन बाय द साइकिल ऑन द रोड इज. सो बेसिकली वर्क पूछा जा रहा है स्टूडेंट्स यहाँ पर. इसका जो सही आंसर है ऑप्शन सी है 0, बिकॉज एज वी टॉक अबाउट वर्क, वर्क इज द फोर्स इनटू डिस्प्लेसमेंट वेदर इट इज अ वेरिएबल फोर्स और अ कांस्टेंट फोर्स. सो बट द डिस्प्लेसमेंट इन दैट केस, द डिस्प्लेसमेंट ऑफ द रोड is 0. So displacement of the road is 0. So हमसे पूछा work by the cycle on the road. So what is the displacement of the road in this case? So it is basically 0. So we can say that in that sense work is equal to 0. सो फोर्थ का जो आंसर है वो हमारे पास जो है दोस्तों वो है ऑप्शन सी. आगे चलते हैं क्वेश्चन नंबर 5 की तरफ. अ बॉडी इज फॉलिंग फ्रीली अंडर द एक्शन ऑफ ग्रेविटी अलोन इन वैक्यूम. फॉर वैक्यूम में बॉडी है, इट इज ओनली अंडर द एक्शन ऑफ ग्रेविटी. सो एज यू नो दैट वी कैन नॉट शील्ड, like if we put something in some jar where there is no gravity, but we cannot shield that jar from gravitational forces. uh, and in some that type of space where there is no air, it is vacuum is there. so वहाँ पूछा जा रहा है बॉडी फ्रीली फॉल कर रहा है, उसका कौन सा क्वांटिटी है जो वो कांस्टेंट रहेगा वहाँ पर. तो स्टूडेंट्स ऑब्वियसली इसका जो टोटल मैकेनिकल एनर्जी है वो कंजर्व रहेगा एज वेन एवर इट इज़ कमिंग डाउनवर्ड्स. उसका जो काइनेटिक एनर्जी है वो इंक्रीज़ करेगा एंड उसका पोटेंशियल एनर्जी जो है वो डिक्रीज़ करेगा. सो बोथ विल नॉट बी कांस्टेंट, बट वी कैन से दैट द टोटल यानी कि टोटल मैकेनिकल एनर्जी इंडिविजुअली, kinetic energy, some of the kinetic energy is being converted into potential energy converted to kinetic energy. This type of thing is there basically whenever a body is going downwards under the influence of gravitational force. So its kinetic energy will increase and potential energy will fall. But the sum of the kinetic energy and potential energy, that is mechanical energy, which is conserved. So C is the correct answer for the fifth question. And let's come to the sixth question. अगले question की तरफ चलते हैं students. During inelastic, it is inelastic collision between the two bodies, which of the following quantities will always remains conserved? So in inelastic collision there is no conservation of kinetic energy, some of the loss of kinetic energy there, so this is not correct. Some of them basically energy is being not conserved there. We cannot say about the total mechanical energy because in inelastic collision some of the energy is being lost in the form of heat, some of the energy is being lost in the form of sound to the ground as well as to the surroundings. So some of the heat or energy being lost in the form of heat as well as sound. So we can say that it's total mechanical energy, total kinetic energy is not conserved, but the momentum of the system, because like it is a collision between the two bodies, so it is just forming like a isolated system. That system is made up of these two bodies, so we can say that the momentum of the system remains conserved. So option C is the correct answer for the question number 6. Let's now come to the seventh question of this NCERT exemplar exercise. So we have two inclined frictionless tracks, one gradual and other one steep, meet at A where two stones are allowed to slide down from the rest, one on each track shown in the figure. Which of the following statement is correct? So we have to identify that which statement is correct. Let's look into the figure there. So this is the figure. Like here this is point A where the two planes, inclined planes, are meeting. So plane like this plane, one plane is gradual, it is not so much steeper, and this one is steeper, but one thing common is that both are at height h. like उनका जो टॉप मोस्ट पॉइंट है जहाँ से बॉडी को रिलीज करना है, it is at height h for both of these inclined planes. Theta are obviously different because one is gradual, other one is steeper. So both the stones reach the bottom at the same time but not with the same speed. Both stones reach the bottom with the same speed but one reaches the bottom earlier than the stone 2. ये clear cut जो है वो गलत statement है. Both reach at the same time but not with the same speed. So let's look into that why this is not the answer. Basically the answer is question में, that is friends, both the stone reach the bottom with the same speed and stone 2 reaches the bottom earlier than the stone 1. सो सी इज द आंसर. बट लाइक जैसे ही आप बॉडी को यहाँ से रिलीज करोगे, सो some potential energy is being converted into the kinetic energy. So here at height h, the body possess its potential energies mgh for the inclined plane 1 as well as for inclined plane number 2. So this potential energy is being transformed into the kinetic energy. So in both the cases, that mgh is equal to half m v square. So that is the case there. So for both the cases, both the stones are reaching at the bottom with the same speed, because this form of energy is being transformed into the kinetic energy. And दोनों ही stones के लिए top तो है वो same है, point A is same at height h, so both having the same initial amount of potential energy. So it being transformed into half mv square. यहाँ से हमारे पास जो v square का या v का आंसर आ जाएगा, it is simply root 2gh. So both are reaching at the bottom with the same speed, but now stone 2 reaches the bottom earlier than the stone 1. So thing here is that because this uh, plane is very steeper, so acceleration is like simply a is equal to g sine theta. Acceleration is equal to g sine theta, sorry, acceleration is equal to g sine theta whenever you are on some inclined plane. That is the expression for acceleration. So here we can say that in the case number 2, theta is more, so sine theta is more. So we can say that acceleration of the ball or the stone on the plane 2 is more. Acceleration is more on the plane 2 because expression for acceleration is a is equal to g sine theta. So here it is more steeper, acceleration for the stone is more there. So because of this reason, it is reaching earlier in comparison to this first one. So both reach with the same speed, but stone 2 reaches the bottom earlier than the stone 1. Thank you very much.